I'm going to try to implement the dragging of spheres on the Graph3D class. Probably to do this, I'm gonna have to spend some time studying this stuff here, because this is the way that I tried to implement last time, and it wasn't working, but I was trying to implement from the camera. So now I'm gonna try to implement from the GraphNode3D. And I'm also probably gonna study the rigid body 3D to see if there is in read the documentation as well, to see if they have a function to ray trace the sphere. I'm gonna read the documentation, this thing. Then, because I think that the best way to figure out is probably to read the documentation. Trying to think about how to, what is the best, maybe not even the best, only just a way to see if the mouse is inside of the sphere or not. The thing that is kind of weird is that the rigid body 3D by itself doesn't have a shape. So that's what I'm contemplating right now, because the first thing that I thought is to get the sphere mesh, and then I think that the easiest way that I can think about it, the only way that I can think about it so far is to get the sphere mesh, then get the shape, get the radius of the sphere, the position of the rigid body 3D, and get the area of the sphere. Then after projecting the mouse position, you do a condition to see if it is inside of the area or not. Which might be complicated because of math, like how you're gonna know. So like trigonometry, it might be annoying based on the signs and stuff like that. But I think that with the LLMs, it's gonna be hopefully relatively easy to figure that part out. But I'm not really sure because I do remember on the documentation that I've seen in the past that they have but I don't remember really well if it was like a function that says that you a function that allows you to just retrieve whether or not the object was set in the rigid body 3D. But maybe I read somewhere and I confused with other things, or maybe it wasn't because I couldn't find there on the source code. So, and this other way here was the way that I was trying to do it with the camera, but it wasn't working because for some reason it wasn't hitting the object. Which this is the part that I'm trying to clarify because if the rigid body 3D itself doesn't have a shape, then how is it possible to ray trace? The only thing you can ray trace makes that the only thing that would make sense to ray trace would be the sphere mesh, which is the thing that has the geometry. So either is something that I'm not setting on the rigid body 3D, which I also kind of think is weird because it doesn't have anything there from Godot. So let's delete these ones. And these ones. I'm gonna change this later, but I'm thinking about increasing the speed as well. The problem is that because the way based on the way that they made this, they made it with an inertia when you zoom in and out. And a lot of the times in the beginning is kind of annoying to zoom in or zoom out because of it doesn't have momentum, I think, based on the way that they created this. The other thing that's kind of annoying, even on the editor itself, is that depending on the way that you move the camera, it becomes hard to get very close to the object or very far away. But I think for solving that's probably a lot harder, so I'm not really sure if I'm gonna spend this time trying to think about a solution because of the relative coordinates of the camera. So like zooming is actually dulling, but in the way that they did it here. So they're just moving the camera closer to in the Z direction, I think. So I think the only thing to do is I'm gonna read the documentation first. The physics server. I'm pretty sure that the class that runs when you run a 3D simulation is the Godot physics server or something like that. And the physics server 3D is just the base class for that. Which I kind of don't like, but they probably have a reason for it. So I guess I have to, if I can't find anything directly on the documentation, I just have to spend a bunch of time. I'm just gonna run the debugger to figure out, to look for breakpoints, then run the debugger, then see what classes exactly are the ones being used, and then study those classes. But I'm pretty sure it's gonna be the Godot Physics server or something like that. The class that that VS Codium is going with when you press F12. Let's see if I can put the sound.
You still find outdated information, please open an issue. Physics Introduction. In game development, you often need to know when two objects in the game intersect or come into contact. This is known as collision detection. When a collision is detected, you typically want something to happen. This is known as collision response. Godot offers a number of collision objects in 2D and 3D to provide both collision detection and response. Trying to decide which one to use for your project can be confusing. You can avoid problems and simplify development if you understand how each works and what their pros and cons are. In this guide, you will learn Godot's 4 collision object types, how each collision object works, when and why to choose one type over another. Note, this document's examples will use 2D objects. Every 2D physics object in collision shape has a direct equivalent in 3D, and in most cases they work in much the same way. Collision objects. Godot offers 4 kinds of collision objects which all extend COLLISIONOBJECT2D. The last 3 listed below are physics bodies and additionally extend PHYSICSVODY2D, AREA2D. AREA2D nodes provide detection and influence. They can detect when objects overlap and can emit signals when bodies enter or exit. And AREA2D can also be used to override physics properties such as gravity or damping in a defined area. STATICBODY2D. A static body is one that is not moved by the physics engine. It participates in collision detection but does not move in response to the collision. They are most often used for objects that are part of the environment or that do not need to have any dynamic behavior. RIGIDBODY2D. This is the node that implements simulated 2D physics. You do not control a rigid body 2D directly, but instead you apply forces to it, gravity, impulses, etc. And the physics engine calculates the resulting movement. Read more about using rigid bodies. CHARACTERBODY2D. A body that provides collision detection but no physics. All movement and collision response must be implemented in code. Physics material. Static bodies and rigid bodies can be configured to use a physics material. This allows adjusting the friction and bounce of an object and set if it's absorbent and or rough. Collision shapes. A physics body can hold any number of shape 2D objects as children. These shapes are used to define the object's collision bounds and to detect contact with other objects. Note, in order to detect collisions, at least one shape 2D must be assigned to the object. The most common way to assign a shape is by adding a collision shape 2D or collision polygon 2D as a child of the object. These nodes allow you to draw the shape directly in the editor workspace. Important. Be careful to never scale your collision shapes in the editor. The scale property in the inspector should remain 1:1. When changing the size of the collision shape, you should always use the size handles, not the node 2D scale handles. Scaling a shape can result in unexpected collision behavior. Physics process callback. The physics engine runs at a fixed rate, a default of 60 iterations per second. This rate is typically different from the frame rate, which fluctuates based on what is rendered in available resources. It is
So the one class that I didn't see there, but maybe I think that's because based on tutorials I've seen before, you're supposed to add a mesh instance 3D as a child for the shape, and to add a collision as well. And that's the reason why I did it like this. So but it's weird because rigid body 3D seems to inherit from collision as well. It's collision object 3D and the other is collision shape. Probably the way to do it is by checking on the collision class. So you create the shape of the collision in the same with the same parameters as the mesh instance 3D. So use a higher level class to couple the properties together. Because there is an article about the guy that I forgot, but it's somewhere on the Godot official site on the articles that they did it like this because they thought it would be better to design this way based on the other like design considerations on Godot's. So Unity is different where they have only one class, and they, as far as I understand now, based on what the article says as well, they do a more composition approach where they, on the base class, let's say, they allow you to compose both the shape and the mesh of the shape. But on Godot, the way that they did it is like different class hierarchies, and then if you want to merge the two, then you create another class, and then which is what I'm doing now, and then you wrap functions to change the state of both of the shape and the mesh. So let me see quickly if there is anything. I am setting this shape, I think. Yeah, set shape, just your shape. Maybe this is an error. Yeah, so it might be because of this that it wasn't working before. Because I'm making the shape separate from the mesh instance 3D. Or the mesh sphere, which is the mesh instance 3D. The mesh sphere is the primitive mesh. So mesh instance 3D is a class that has as a member variable reference to a mesh, which is ref mesh on Godot. And that mesh is a primitive mesh for like the standard options you have on the editor is going to be classes that inherit. It's mainly going to be the primitive mesh. So all the other shapes are classes that inherit from primitive mesh, which inherits from mesh. And then on mesh in 3D, you have the mesh type as a reference, which is what's going to define the shape of the mesh. Yeah, so I have to see, because this has height and radius, but I think I can put, like, it doesn't have to be perfect as long as it's like good enough, I think. So I have to see if I can set maybe I have to set values here. Yeah, set radius. This is kind of annoying as well. Like on the other thing they have, I guess I'll just put the greater one because then is like the error is gonna be uh, maybe it should be the smaller one actually. Yeah, I think I'm gonna put the smaller one. But like I said, it's probably not that big of a deal. This is a problem, I think, because I think I'm initializing, and maybe it's gonna work. Yeah, so I should probably put them on the same function, I think. Yeah. So I'm gonna leave the functions separate here, but I'm going to put the other one because I'm pretty sure, yeah, I think I'm initializing. Hmm. So the question is whether or not should create another function and then just call all these other functions. I think yeah, I would have to call only two of them. But then like what would be the point of having the other ones? Because these functions only matter for our initialization. So I think I should remove one of them probably. I should remove the collision shape probably. I should remove the collision shape and just leave this one, I think. So I'm gonna put this stuff here. It should be, yeah, it should be here. Initialize sphere. Yeah, so now it guarantees that I'm gonna have the sphere shape here, or the mesh sphere. So if I do this, so I should probably remove this one. So maybe now the problem is I erased some parts of the thing, so I'm gonna have to search how to do it again. But I do think that it was working when I was trying to do it. So I just have to see from the classes here. I think I have to. Yeah, I guess I can just look into the like what it wants or how to initialize the parameters from this function, and then I can test to see if it works. So I was trying to see if you, when you click, it triggers the thing. And this approach is the one that I was trying to use on the camera 3D that I searched for with LLMs as well. She uses the physics direct space state 3D, which is just basically the physics, and then it intersects the ray, which is basically taking the mouse position from the beginning, the projected mouse position to the end, I think. But the origin is gonna be the camera position, the origin of the camera position, the mouse origin, and then as far as I remember, I think, and this one's gonna be like the mouse position projected as a vector into the 3D space. I think I don't remember really well. I think he uses the mouse, he uses the camera coordinates to get the mouse, the position of the mouse at the beginning, and then it creates a vector in 3D space. Just and then based on if there was anything between the vector, then it gets a collision based on this thing here. Yeah, but so there was something that you have. I think it's the parameters you have to use the mouse origin and the mouse end. But on the camera, I wasn't getting it wasn't hitting anything. But and I wasn't sure, but I think it might be because of the shape there. So yeah, I'll be right back. I'm gonna continue to read there the documentation, and then I'm going to see if I can remember. Should probably just gonna build and then see what happens. Should test, and then if it doesn't work, I try something else. Probably because of the abstract classes, I think. That is like doing this circular thing. Probably the easiest thing to do is to try to implement the same way that I was trying to implement before. I was gonna look into this stuff here. Pretty sure. Yeah. So on the uh, perspective projection is gonna be the camera origin. So just scanning from the camera position, I think. So the global camera position gets that. Ortho normalize. It's basically the global camera position. Why does it receive the mouse position? I think the mouse. Hmm. That's kind of weird. So the mouse is only for the orthogonal projection. I think that makes sense actually, because the orthogonal is gonna be like a straight. It's like a cube, straight cube. So I think in the beginning it makes sense. So orthogonal is probably more complex at the beginning and then simpler in the end, I think. And the other one's the other way around. Yeah. Because on the orthogonal, we're gonna see the depth of the mouse on the beginning, I think. Because there's no distortion based on the 3D. So the projection creates the near plane and creates the far plane. The near plane is what you see on the screen as far as I understand. And the eye is perceived to be like, is like an abstraction used to, as if you were outside of the screen seeing, and then because of the angle of the different planes, it creates the pyramids. It creates the illusion of 3D based on the. So you basically just divide by z, and then you do some other stuff based on the focal length, the calculations that are inside of the matrix. That creates the illusion of 3D. So I think it makes sense that on the beginning for the perspective projection is just the camera, and then for finding the final point where it hits, that's when the mouse matters. The mouse position, because you're getting the vector from the camera origin to the mouse position, I think, projected into the 3D visualization. And then, yeah, it's probably just that. And then that tells you, like, then you can use that to put on the physics server, and the physics server is going to tell if there was any object in between the camera origin and the final mouse position. I think that's what's happening. So I'm not going to spend time on this. So I'll be right back, and I'm going to continue reading the documentation after.
important that all physics-related code runs at this fixed rate. Therefore, Godot differentiates between physics and idle processing. Code that runs each frame is called idle processing, and code that runs on each physics tick is called physics processing. Godot provides two different callbacks, one for each of those processing rates. The physics callback, node, is called before each physics step. Any code that needs to access a body's properties should be run in here. This method will be passed a delta parameter, which is a floating point number equal to the time passed in seconds since the last step. When using the default 60 physics update rate, it will typically be equal to, but not always. See below. Note, it's recommended to always use the delta parameter when relevant in your physics calculations, so that the game behaves correctly if you change the physics update rate or if the player's device can't keep up. Collision layers and masks. One of the most powerful but frequently misunderstood collision features is the collision layer system. This system allows you to build up complex interactions between a variety of objects. The key concepts are layers and masks. Each COLLISIONOBJECT2D has 32 different physics layers it can interact with. Let's look at each of the properties in turn. Collision layer. This describes the layers that the object appears in. By default, all bodies are on layer 1, collision mask. This describes what layers the body will scan for collisions. If an object isn't in one of the mask layers, the body will ignore it. By default, all bodies scan layer 1. These properties can be configured via code or by editing them in the inspector. Keeping track of what you're using each layer for can be difficult, so you may find it useful to assign names to the layers you're using. Names can be assigned in project settings greater than layer names. GUI example. You have 4 node types in your game: walls, player, enemy, and coin. Both player and enemy should collide with walls. The player node should detect collisions with both enemy and coin, but enemy and coin should ignore each other. Start by naming layers 1 to 4 walls, player, enemies, and coins, and place each node type in its respective layer using the layer property. Then set each node's mask property by selecting the layers it should interact with. For example, the player settings would look like this. Code example. In function calls, layers are specified as a bit mask. Where a function enables all layers by default, the layer mask will be given a 0xFF. Your code can use binary, hexadecimal, or decimal notation for layer masks, depending on your preference. The code equivalent of the above example where layers 1, 3, and 4 were enabled would be as follows. Hashtag example. Setting mask value for enabling layers 1, 3, and 4 hashtag binary. Set the bit corresponding to the layers you want to enable 1, 3, and 4 to 1. Set all other bits to 0. Hashtag note. Layer 32 is the first bit, layer 1 is the last. The mask for layers 4, 3, and 1 is therefore 0B000000000 1000 1001 hashtag this can be shortened to 0B10 1101 hashtag this can be shortened to 0B1101 hashtag hexadecimal equivalent 1101 binary converted to hexadecimal 0x this value can be shortened to hashtag 0xt hashtag decimal add the results of 2 to the power of layer to be enabled 1 hashtag 2 1 to 1 2 3 to 1 2 4 to 1 equal to 1 4 8 equal to 13 pow 2 1 to 1 AREA2D. Area nodes provide detection and influence. They can detect when objects overlap and emit signals when bodies enter or exit. Areas can also be used to override physics properties, such as gravity or damping, in a defined area. There are 3 main uses for REA2D: overriding physics parameters such as gravity in a given region, detecting when other bodies enter or exit a region, or what bodies are currently in a region, checking other areas for overlap. By default, areas also receive mouse and touchscreen input. STATICBODY2D. A static body is one that is not moved by the physics engine. It participates in collision detection, but does not move in response to the collision. However, it can impart motion or rotation to a colliding body as if it were moving, using its constant linear velocity and constant angular velocity properties. Static body 2D nodes are most often used for objects that are part of the environment or that do not need to have any dynamic behavior. Example uses for STATICBODY2D. Platforms including moving platforms, conveyor belts, walls, and other obstacles. RIGIDBODY2D. This is the node that implements simulated 2D physics. You do not control a RIGIDBODY2D directly. Instead, you apply forces to it, and the physics engine calculates the resulting movement, including collisions with other bodies, and collision responses such as bouncing, rotating, etc. You can modify a rigid body's behavior via properties such as mass, friction, or bounce, which can be set in the inspector. The body's behavior is also affected by the world's properties, as set in project settings greater than physics, or by entering an AREA2D that is overriding the global physics properties. When a rigid body is at rest and hasn't moved for a while, it goes to sleep. A sleeping body acts like a static body, and its forces are not calculated by the physics engine. The body will wake up when forces are applied, either by a collision or via code, using RIGIDBODY2D. One of the benefits of using a rigid body is that a lot of behavior can be had for free without writing any code. For example, if you were making an Angry Bird style game with falling blocks, you would only need to create rigid body 2Ds and adjust their properties. Stacking, falling, and bouncing would automatically be calculated by the physics engine. However, if you do wish to have some control over the body, you should take care altering the position, linear velocity, or other physics properties of a rigid body can result in unexpected behavior. If you need to alter any of the physics-related properties, you should use the integrate forces callback instead of. In this callback, you have access to the body's PHYSICSDIRECTBODYSTAT2D, which allows for safely changing properties and synchronizing them with the physics engine. For example, here Here is the code for an asteroid-style spaceship. GD script extends RIGID, BODY2D. Note that we are not setting the linear velocity or angular velocity properties directly, but rather applying forces thrust and torque to the body, and letting the physics engine calculate the resulting movement. Note, when a rigid body goes to sleep, the integrate forces function will not be called. To override this behavior, you will need to keep the body awake by creating a collision, applying a force to it, or by disabling the cancel property. Be aware that this can have a negative effect on performance. Contact reporting. By default, rigid bodies do not keep track of contacts, because this can require a huge amount of memory if many bodies are in the scene. To enable contact reporting, set the max contacts reported property to a non-zero value. The contacts can then be obtained via PHYSICSDIRECTBODYSTATE2D.contact count. And related functions. Contact monitoring via signals can be enabled via the contact monitor property. CRIGIDBODY2D for the list of available signals. CHARACTERBODY2D. CHARACTERBODY2D bodies detect collisions with other bodies, but are not affected by physics properties like gravity or friction. Instead, they must be controlled by the user via code. The physics engine will not move a character body. When moving a character body, you should not set its position directly. Instead, you use the move and collide or move and slide methods. These methods move the body along a given vector, and it will instantly stop if a collision is detected with another body. After the body has collided, any collision response must be coded manually. Character collision response. After a collision, you may want the body to bounce, to slide along a wall, or to alter the properties of the object it hit. The way you handle collision response depends on which method you use to move. The CHARACTERBODY2D. Move and collide. When using move, the function returns a kinematic collision 2D object, which contains information about the collision and the colliding body. You can use this information to determine the response. For example, if you want to find the point in space where the collision occurred, GD script TC sharp extends PHYSICSBODY2D VAR velocity equal to vector 2 250 fun physics, or to bounce off of the colliding object. GD script TC sharp. Sliding is a common collision response. Imagine a player moving along walls in a top-down game or running up and down slopes in a platformer. While it's possible to code this response yourself after using move and slide, provides a convenient way to implement sliding movement without writing much code. Warning: move and slide automatically includes the time step in its calculation, so you should not multiply the velocity vector by delta. This does not apply to gravity as it is an acceleration and is time dependent and needs to be scaled by delta. For example, use the following code to make a character that can walk along the ground including slopes and jump when standing on the ground. GD script TC sharp extends CHARACTERBODY. See kinematic character 2D for more details on using move, including a demo project with detailed code. User contributed notes. Please read the user contributed notes policy before submitting a comment. Godot Engine 4.3 documentation in English. What is a rigid body? A rigid body is one that is directly controlled by the physics engine in order to simulate the behavior of physical objects. In order to define the shape of the body, it must have one or more SHAPE3D objects assigned. Note that setting the position of these shapes will affect the body's center of mass. How to control a rigid body? A rigid body's behavior can be altered by setting its properties such as mass and weight. A physics material needs to be added to the rigid body to adjust its friction and bounce, and set if it's absorbent and or rough. These properties can be set in the inspector or via code. See RIGID-BODY3D and physics material for the full list of properties and their effects. There are several ways to control a rigid body's movement, depending on your desired application. If you only need to place a rigid body once, for example to set its initial location, you can use the methods provided by the GraphNode3D node, such as cyclical transform or Luca. However, these methods cannot be called every frame, or the physics engine will not be able to correctly simulate the body state. As an example, consider a rigid body that you want to rotate so that it points towards another object. A common mistake when implementing this kind of behavior is to use Lookat every frame, which breaks the physics simulation. Below, we'll demonstrate how to implement this correctly. The fact that you can't use cyclical transform or Lookat methods doesn't mean that you can't have full control of a rigid body. Instead, you can control it by using the integrate forces callback. In this method, you can add forces, apply impulses, or set the velocity in order to achieve any movement you desire. The Lookat method, as described above, using the GraphNode3D's Lookat method, can't be used each frame to follow a target. Here is a custom Lookat method called lookfollow that will work with rigid bodies. GD script C# extends RIGID-BODY3D VAR speed. This method uses the rigid body's angular velocity property to rotate the body. The axis to rotate around is given by the cross product between the current forward direction and the direction one wants to look in. The clamp is a simple method used to prevent the amount of rotation from going past the direction which is wanted to be looked in, as the total amount of rotation needed is given by the arcosine of the dot product. This method can be used with axis lock angular as well. If more precise control is needed, solutions such as ones relying on quaternion may be required, as discussed in using 3D transforms. User contributed notes. Please read the user contributed notes policy. Godot Engine 4.3 documentation in English. Physics, raycasting. One of the most common tasks in game development is casting a ray or custom-shaped object and checking what it hits. This enables complex behaviors, AI, etc. to take place. This tutorial will explain how to do this in 2D and 3D. Godot stores all the low-level game information in servers, while the scene is only a front end. As such, raycasting is generally a lower-level task. For simple raycasts, nodes like Raycast3D and Raycast2D will work, as they return every frame what the result of a raycast is. Many times, though, raycasting needs to be a more interactive process, so a way to do this by code must exist. Space. In the physics world, Godot stores all the low-level collision and physics information in a space. The current 2D space for 2D physics can be obtained by accessing canvas item get space. For 3D, it's NODE, 3D get space. The resulting space rate can be used in PHYSICSSERVER3D and PHYSICSSERVER2D respectively for 3D and 2D. Accessing space. Godot physics runs by default in the same thread as game logic, but may be set to run on a separate thread to work more efficiently. Due to this, the only time accessing space is safe is during the node.physics process. Callback. Accessing it from outside this function may result in an error due to space being locked. To perform queries into physics space, the PHYSICSDIRECTSPACESTATE2D and PHYSICSDIRECTE3D must be used. Use the following code in 2D. GD script fun physics process delta. VAR space rate equal to get space. VAR space state equal to PHYSICSSERVER2D space get direct state space rate. Copy to clipboard public override void physics process double delta VAR space rate equal to get world space. VAR space state equal to PHYSICSSERVER2D space get direct state space rate. Copy to clipboard. Or more directly, GD script fun physics process delta. VAR space state equal to get direct space state. Copy to clip. Raycast query. For performing a 2D raycast query, the method PHYSICSDIRECTSPACESTATE2D intersect may be used. For example, GD script fun physics process delta. VAR space state equal to get direct space state. Hashtag use global coordinates not local to node var query equal to PHYSICSRAYQUERYPARAMETERS2D create vector 20. 0 vector 250 100 VAR result equal to space state intersector query. Copy to clipboard public override void physics process double delta. VAR space state equal to get world direct space state. Use global coordinates not local to node var query equal to PHYSICSRAYQUERYPARAMETERS2D create vector 2 0 new vector 250 var result equal to space state intersector query. Copy to clipboard. The result is a dictionary. If the ray didn't hit anything, the dictionary will be empty. If it did hit something, it will contain collision information. GD scripts if result print hit at point result opposition copy to clipboard. If result count greater than 0 GD print hit at point result. The result dictionary when a collision occurs contains the following data. The data is similar in 3D space using vector 3 coordinates. Note that to enable collisions with a REA3D, the Boolean parameter collide with areas must be set to true. GD script const ray length equal to 1000 fun physics process delta. VAR space state equal to get direct space state. VAR cam equal to CAMERA3D var mouse post equal to get it mouse position.
Hmm. Let's see if this compiles. But
var origin equal to cam.project origin mouse bus. var end equal to origin cam.project normal mouse bus. Ray length var query. Common use case for ray casting is to enable a character to gather data about the world around it. One problem with this is that the same character has a collider, so the ray will only detect its parent's collider, as shown in the following image. To avoid self-intersection, the intersect ray parameters object can take an array of exceptions via its exclude property. This is an example of how to use it from a CHARACTERBODY2D or any other collision object node. GD script TC sharp extend CHARACTERBOD. The exceptions array can contain objects or RIDs, collision mask. While the exceptions method works fine for excluding the parent body, it becomes very inconvenient if you need a large and/or dynamic list of exceptions. In this case, it is much more efficient to use the collision layer mask system. The intersect ray parameters object can also be supplied a collision mask. For example, to use the same mask as the parent body, use the collision mask member variable. The array of exceptions can be supplied as the last argument as well. 2D or any other collision object node. GD script TC sharp extend CHARACTERBODY2D func physics process delta. VAR space state equal to get space state. Var query equal to PHYSICSRAYQUERYPARANETERS2D. Create global position. Target position collision mask self VAR result equal to space state intersect ray query. Copy to clipboard using Godot. Public partial class my character body 2D. Character body 2D public override void physics process double delta. VAR space state equal to get world direct space state. Var query equal to see code example for details on how to set the collision mask. 3D ray casting from screen. Casting a ray from screen to 3D physics space is useful for object picking. There's not much need to do this because COLLISIONOBJECT3D has an impute event signal that will let you know when it was clicked. But in case there is any desire to do it manually, here's how. To cast a ray from the screen, you need a CAMERA3D node. A CAMERA3D can be in two projection modes, perspective and orthogonal. Because of this, both the ray origin and direction must be obtained. This is because origin changes in orthogonal mode, while normal changes in perspective mode. To obtain it using a camera, the following code can be used. GD script const ray length equal to 1000 func input event. If event is input event mouse button and event top pressed. And event dot button index equal to 1. VAR CAMERA3D equal to CAMERA3D var from equal to CAMERA3D project ray origin event dot position. VAR2 equal to from CAMERA3D project ray normal event dot position. Ray length copy to clipboard private const float ray length equal to 1000 Fahrenheit. Public override void input impute event. If event is input event mouse button, and an event mouse button pressed. And an event mouse button dot button
so
index.
this is the part that I was talking about. Is an events on the collision object 3D. But this is the thing that is weird because like if it doesn't have a shape, how is it gonna know? And maybe it does have a shape and I have to set the shape. Yeah, I think I have to set the shape. It's weird that it doesn't have anything though on the editor, so if it does have if I'm able to use this function, then it becomes a lot easier because I can just set a signal to this function, then just flip the boolean, and then on the other one, hopefully it works. The other one might be very annoying as well because of the translation between coordinates. So like figuring out how to move the object uh, with the mouse movements. But I think it's easier to figure that out than to figure out how to do the intersection. So I'm probably just gonna read the documentation there. And it is weird that it has this value here, so like obviously it makes sense that at some point it's gonna use this, but I couldn't find where. Yeah, so I have to understand. So probably once I initialize the mesh, I'm going to, if I do have to set the shape, I'm just going to do it in the same place that I'm initializing the mesh. I don't like this as well because like there's so many things that I have to create, so it feels kind of um, it makes it easier to make a mistake if you have a bunch of stuff. It feels kind of weird. So because then like what would be the point of having a collision? So I think if I can do the shape based on this, then I should probably get rid of the collision and just do the shape. Because I think that the main point of having the collision as a child of the rigid body is so that, or maybe it creates the shape based on the children. That might be how it works. Oh, I forgot. I think just put 0 here if I remember. I think you put 0 and then you put an empty object there. That's how I did it the last time. I think this one is to specify like the masks the layers you want to check for the collision, but probably passing 0 is fine. And the other ones should exclude an object. So this is probably because they changed. So uh, the LLMs have another version. Or maybe it's just no. It has to be from the actually I'm not even sure if the camera is supposed to have global mouse position. Yeah, I think it's just a hallucination, that one. Should probably try to get the mouse position based on the projection again. But there was a way, I think. There is a way because that's how I was trying to do before, but I don't remember really well how. Because it was outside of the event, and uh, I was able to get the mouse position. But maybe, yeah, mm, yeah, but just getting the mouse position from the beginning doesn't work, I think. No, I think it was like that. So you get first from the first you get when the event happens, and then you update inside of the function, I think. But I'm not really sure about that.
Equal to equal mouse button dot left vr camera 3D equal to get nodeless and camera 3D GT. To cast array from the screen, you need a CAMERA3D node. A CAMERA3D can be in two projection modes, perspective and orthogonal. Because of this, both the ray origin and direction must be obtained. This is because origin changes in orthogonal mode, while normal changes in perspective mode. To obtain it using a camera, the following code can be used. GD script const ray length equal to 1000 func input event. If event is input event mouse button and event top pressed. And event dot button index equal to 1. VAR CAMERA3D equal to CAMERA3D var from equal to CAMERA3D project ray origin event dot position. VAR to equal to from CAMERA3D project ray normal event dot position. Ray length copy to clipboard private const float ray length equal to 1000 Fahrenheit. Public override void input impute event. If event is input event mouse button, and an event mouse button pressed. And an event mouse button dot button index equal to mouse button dot left VAR camera 3D equal to get node list and camera 3D GT camera VR from equal to camera 3D project ray origin event mouse button dot position. VAR equal to from CAMERA3D project ray normal event mouse button dot position ray length copy to clipboard. Remember that during the space may be locked, so in practice this query should be running. Godot engine 4.3 documentation in English. All classes. CO. Abstract base class for 3D physics objects. COLLISIONOBJECT3D can hold any number of shape 3Ds for collision. Each shape must be assigned to a shape owner. Shape owners are not nodes and do not appear in the editor, but are accessible through code using the shape owner methods. Warning: with a non-uniform scale, this node will likely not behave as expected. It is advised to keep its scale the same on all axes and adjust its collision shape. Abstract base class for 3D physics objects. COLLISIONOBJECT3D can hold any number of shape 3Ds for collision. Each shape must be assigned to a shape owner. Shape owners are not nodes and do not appear in the editor, but are accessible through code using the shape owner methods. Warning: with a non-uniform scale, this node will likely not behave as expected. It is advised to keep its scale the same on all axes and adjust its collision shapes instead. Properties: int collision layer 1, int collision mask 1, float collision priority 1, disable mode 0, bool input capture on drag false, bool input tray pickable true, methods void input event camera CAMERA3D event impute event position vector 3 normal vector 3 shape x int virtual void mouse center virtual void mouse exit virtual int create.
Hmm. I guess the easiest way to figure out, it's kind of annoying because this is a macro that they use, and then it's based on the script functionality, and it's probably not gonna be, I'm not gonna be able to figure out by stepping over, I think. On this one because the debugger stops on the macro. But maybe there is like, if you step over, it goes through other functions. But I wanted to understand like how does they uh how do they know when the object was hit? But yeah, it's gonna be inside of the function, so that's the thing. Yeah, so it's called input event call here, but the name there that they say is input event because they are talking about GD script. So they're calling the function from here. Hmm. Oh, I can see here maybe. And it's just gonna be this. So obviously I can connect there. Yes, so I think that the easiest way is to connect. It's still annoying though because I'm not really like the problem is if I don't understand how they what is the process that they use to see if the mouse is inside of the if there was a click inside of the object or the collision shape or not, then it's gonna be more likely that I'm not gonna be able to know if the stuff that I'm using to move the object is gonna be correct. This is the issue. It needs to move based on the mouse. So I think I can just put here. Oh yeah. Now this is the other problem. Like how I'm gonna set. I guess I still need the event to see. Hmm. Yeah, so when these events gonna be only like for this condition here. So I pass this stuff here, and then I update the last value. I think I don't need this. Just gonna switch the variables. And just last time I just copied this to do later. I think the only one I need is this one. But this is the problem here because if I do like this, I think that it's probably not gonna work. So I should probably just because the issue is you need a depth, and I think the depth is gonna determine how like the length of the vector, but it's not gonna be an accurate representation of where exactly the mouse is. Or maybe it will, yeah, but actually it won't because of the depth. So maybe I'll do the depth based on the position. Yo, thank you for the message. Hmm. I should probably create another function and then just put the stuff to updates. Because I'm gonna be doing. Actually, I'm gonna. It's just gonna be here and here, I think. Also, they send the event position as well, so I don't need to convert. So probably what I'm gonna do. Yeah, but it's still a problem because I need to figure out how to convert here. So I'm gonna test first, I think, to see if this works, and then if it doesn't work, I'm going to see if I can step over just to figure out how they do the translation, or how does the input event function on the collision shape works. Also, the other thing I have to figure out before this is whether. Yeah, is how the collision object creates the shape. If it creates based on the children, or if I should set the shape and then change the class there. I think the easiest way to see. It doesn't look like it has children, child. Yeah, but it does. I think this is the warning that shows there when you don't have children. So let me see where this. Hmm. So what is going on? I guess that should be on the other classes. Oh, so it does based on the transform of the rigid body. How does that make sense? So that should be here. Probably. So I guess I can do it with this instead of doing with the normal events as well. So I can just flip there. But now the question is like I want to make sure that I have the shape in the correct way, because then obviously like if I test like this, I'm not gonna be able to know if like it's failing because of the shape or something else. Let me
Emitted when the object receives an unhandled input event. Event position is the location in world space of the mouse pointer on the surface of the shape with index shape at x, and normal is the normal vector of the surface at that point. Mouse entered. Emitted when the mouse pointer enters any of this object's shapes. Requires input tray pickable to be true and at least one collision layer bit to be set. Note: due to the lack of continuous collision detection, this signal may not be emitted in the expected order if the mouse moves fast enough and the COLLISIONOBJECT3D's area is small. This signal may also not be emitted if another collision object 3D is overlapping the collision object 3D in question. Mouse exited. Emitted when the mouse pointer exits all this object shapes. Requires input tray pickable to be true and at least one collision layer bit to be set. Note: due to the lack of continuous collision detection, this signal may not be emitted in the expected order if the mouse moves fast enough and the COLLISIONOBJECT3D's area is small. This signal may also not be emitted if another collision object 3D is overlapping the collision object 3D in question. Enumerations: enum disable mode, disable mode remove equal to 0. When node.process mode is set to node.process mode disabled, remove from the physics simulation to stop all physics interactions with this COLLISIONOBJECT3D. Automatically re-added to the physics simulation when the node is processed again. Disable mode make a static equal to 1. When node.process mode is set to node.process mode disabled, make the body static. Doesn't affect AREA3D. PHYSICSBODY3D can't be affected by forces or other bodies while static. Automatically set PHYSICSBODY3D back to its original mode when the node is processed again. Disable mode keep active equal to 2. When node.process mode is set to node.process mode disabled. Do not affect the physics simulation. Property descriptions: int collision layer equal to 1. Void set collision layer value int to get the physics layers the COLLISIONOBJECT3D is in. Collision objects can exist in one or more of 32 different layers. See also collision mask. Note: object A can detect a contact with object B only if object B is in any of the layers that object A scans. See collision layers and masks in the documentation for more information. Int collision mask equal to 1. Void set collision mask value int get the physics layers this COLLISIONOBJECT3D scans. Collision objects can scan one or more of 32 different layers. See also collision layer. Note: object A Godot engine. RIGIDBODY3D implements full 3D physics. It cannot be controlled directly, instead you must apply forces to it, gravity, impulses, etc. And the physics simulation will calculate the resulting movement, rotation, react to collisions, and affect other physics bodies in its path. The body's behavior can be adjusted via lock rotation, freeze, and freeze mode. By changing various properties of the object such as mass, you can control how the physics simulation acts on it. A rigid body will always maintain its shape and size, even when forces are applied to it. It is useful for objects that can be interacted with in an environment, such as a tree that can be knocked over, or a stack of crates that can be pushed around. If you need to override the default physics behavior, you can write a custom force integration function. See custom integrator. Note: changing the 3D transform or linear velocity of a RIGIDBODY3D very often may lead to some unpredictable behaviors. If you need to directly affect the body, prefer integrate forces as it allows you to directly access the physics state. Tutorials: physics introduction, 3D truckdown demo, 3D physics test demo, properties, float, angle.
Oh, I think that I understand now. So I think that the problem is that I don't know based on the code there, but what I assume is happening is that every time you add a child of the rigid body 3D is gonna add a shape to the collision. So the RID is gonna be the resource ID of the thing that you added as a child. But I still obviously don't understand the relationship between the events there and whatever. So this node has no shape. This node. So I guess that this warning, the first warning is uh, maybe both have to be from the rigid. The thing is that there's only one warning here. So I'm gonna search for the full thing. This node has no shape, so you can't collide. So it's coming from here. Uh, like it has to listen to an event, I think. So what I'm gonna do is put breaking points on these functions here. I should probably, so probably the first thing that I should do is test to see if it works. If I, so like I'm gonna set based on the events that they have there to see. The problem is, no, I do think that the event that they have is if the mouse, no, but it doesn't work. I think the only one that matters is when you click for the first time, and then I should probably make the flag variable false inside of the GraphNode3D input function. Because I think that the events there, like obviously, like after the first time that you click, it's never gonna leave the. It's never gonna leave the object. So the only way to see if it's not, if you should stop dragging is through the is pressed, I think. Check if the mouse is pressed. So I think you should probably first check to see if it works to flip the variables based on those functions. Then after I do this, I should put breakpoints there and try to understand how do they manage to know whether or not the mouse intersected with the shape, and then after that I can extract the logic that I think is necessary, and then I put that on the physics process so that if the flag variable is true, then I update the position of the object based on the same way that they get the mouse position. I think that's what makes the most sense. Hmm. Oh, so I think I understand what's going on. So when you add a child, it's gonna trigger this event probably. So I should actually see if that's the case. So the problem is that on the like on here is not a direct string that they send. So it should. Hmm. That's, so maybe it could be Node 3D. Hmm. Oh, but it shouldn't be this. So like, probably the easiest way to just ask here. Problem is that I think that they have an older version of Godot on the like the data that created the model, so it's probably not going to give a very accurate answer. Yeah, it's like just Hmm. Yeah, so it's probably getting the shape from here. Maybe it's here. Here is only gonna update the warnings. So the only thing that makes sense is that it's done through the physics server. So if the function is not called explicitly, then the only thing that makes sense is that. The problem is like the thing that is kind of confused is that I can't. It seems that there's no connection between because it can't be something that maybe I should see if I can get the like all the signal names that are triggered after add child and all the notification and then see if there's any function that is run, but it seems that there isn't any function that is run after that. So this is the thing that is kind of weird. Like how does maybe just the warning goes away when you add the child, but nothing really happens. Like it doesn't set any shape. So I should probably look for the anything related to the warning. So it does based on these shapes here, I think. So it's definitely this one. So just have to figure out how the hell. So maybe on the collision shape it has. I think when you set the collision shape, it probably has a function. Maybe. Hmm. Yeah. So it sets here. This is kind of weird as well. It's like I don't know. It doesn't make a lot of sense. Wouldn't it make more sense that the object is the instance? Like based on the way that it is there, it seems that I have to initialize the collision shape and then set the collision object to be the same as the collision shape. Although I think it's a different thing. Ah, this is collision object. Yeah, so I need to, but it looks like there is no way to set this. Oh, I think that it probably does through here though. Hmm. Yeah, so that's how it works. So I think that this one probably happens when you add the node as a child of the other one. So you guess the parents and then cast your collision object, and then assess the shape on the collision object. And this is the thing that makes me think that probably like it doesn't feel very. It feels that this is overly complicated, to be honest. But I haven't seen Unity's code to know for sure. And it might be because of the overall design of the of Godot, but it doesn't feel right. It's just so weird. I think that like if you do, it's probably because of the design, the whole design. But it doesn't, because like based on the design, we are forced to create the boundaries between things uh, in different classes. Like you have to create different classes because that's how the whole engine works. So like if you're gonna make an edge case for each thing that you wanna add as a like a custom thing, then it becomes like it defeats. It goes against the structure of the design. And obviously everyone's gonna have their own like use case. But I'm not sure. I'm not really sure because it could be as well like just one of those things where like because the nature of how people do things like they either go with a full composition or full object oriented, and it's just like the nature of how things evolve. But reality is gonna be more likely to be somewhere in the middle, like the optimal solution. And I think it's exactly the same thing that I felt on the. I do think it's a problem like with the design. There should be a like a more simple way. That's how, if I'm being honest, because it's exactly the same thing that I felt on the curve 3D. Like it just didn't make sense to put like the problem is like the boundary where you decide to separate the concerns. So it didn't make a lot of sense to create one class and then have to create another class just to create a curve. It made more sense to put the data as variables of the first class and then encode on functions, because essentially the difference between functions and classes is just going to be the scope. Like it's how is the how the memory of the data is going to be managed. So y y y I think it is definitely overly complicated if you create like create another class just to create a curve and then like the curve parameters, and then you use the other class to draw on top of that curve. That makes sense. Even if you have more generic objects, I do still think that it makes a lot more sense to just put as functionality of the main class. And I think it's basically the same thing that I'm feeling here. Like I'm not really sure if it makes sense, but I'm not gonna take the time to change this because it's gonna be too much work, I think. They're just gonna have to. So the main thing is gonna be this thing here, and probably not gonna be able to see from the debugger what is going on. I'm just gonna put music here. And maybe at some point it does make sense to try to create another class and just like yeah, maybe it does make sense to do this. So I could just get the code that is responsible for checking the whether or not, because that's essentially the only thing that I'm looking for. But I'm not really like the only thing I'm looking for is to see if the mouse is inside of the thing, and then when you click, basically just implement the dragging on the node. But the thing is, I'm not really sure if I'm going to use other stuff later. So that's the problem. So yeah, I think for that reason it might not be, because then I would have to change the whole physics, I think. And that's like gonna be, and I'm not really even sure if I'm gonna use the jolt thing as well. So what I was gonna do? Yes, so now I know that the shape comes from the shape. You have to set the shape on the collision shape 3D, and then the other one's gonna use that to check. So this was probably the issue that I was having before, is because I didn't set the shape on the collision. I guess I can. Yeah, let me see. So if you don't set, it sets the warning. Yeah, but I do the yeah do this. So this is the other thing that is kind of weird because so I have to see. But I am setting the radius. It's weird that you can set from here. I guess you can. Yeah. Oh, sorry. It's set from here. Okay, so that makes sense. So now probably the best thing to do is to test this. Still have to see how to. Because on the physics process, it's not recommended to use the. No, I think it's the other way around. The event you're not recommended to use the space. So maybe if this works, then I should probably. But I don't need the intersection. So it's probably gonna be. I'm gonna have to test with these methods here. Or I could just use the mouse enter and then get a position from the event that they set. This is probably a better idea. So I just use the mouse enter that they already have as the event. And then I have to see if they're gonna send. If they do send the position, then. But I think that this one they probably don't send. Oh, so I can do everything on this one. Oh, I think I understand now. So this one is the generic one, and then you have. So I think that's gonna be a lot easier. So I don't need to set the inputs event on the other one. I can do everything from here and then just replace the event. So it would be basically the same thing there. Hmm. I think that I don't need the mouse then. Like I don't need to set this if I'm gonna receive from the event. I just do this and then. So I should just copy the types here, because it's just gonna pass. Need this stuff as well. So I do wanna understand. The problem is I'm not re I don't know if I'm gonna be able to figure out how they do the function, but I do want to understand how does that work. Like what functions, what classes and functions are they using to figure out the collision? And I spent some like not too much time, but a little bit of time studying the server, and I do know like both when I was trying to do this and before when I was trying to implement bar and sut, they do have a dynamic BVH, which is a tree data structure that they use to partition the space. And they, I think, pretty sure that they use AMBB, which is access aligned bounding box, to be able to partition the space using a tree. So I'm pretty sure that that's the data structure that they are using to uh, partition the space, and that's the one that the physics server is going to use. So I think the last time that I was stepping over, I remember seeing these functions. So it's probably related to those functions, the way that they are gonna, because the collision is basically uh, related to this. So like, I think those data structures are the ones that are responsible for creating for allowing to calculate the collisions. But obviously, I don't know how are they getting the position of the mouse. Yeah, so maybe it's because of that, but I think that it didn't work, probably. It looks like there is still a problem with the the thing as well. I thought it was fixed, but so it is working. It is calling, but the mouse position is. So maybe if I just set the position instead. Hmm. So it looks like it is staying on the. Hmm. It is staying on the direction of the mouse, but it's obviously because it doesn't have the. So either I can create a. So I think it's gonna work if I do. I'm gonna have to. I thought that the thing was fixed here, the simulation, since last time. I fixed the inputs here, but it looks like it is still broken. So I'm just gonna delete this stuff here because I think the other one's gonna work. I'm gonna spend some time studying trying to see if I figure out, or yeah, figure out how they implement this. And then after that, I'm probably gonna try to solve the calculation there on the graph 3D. But here, I think what is happening is that the z is gonna be 0 for this. So I think that's maybe if I start here. Because it looks like it is staying on the same place that the mouse is at, but then it's just coming towards the camera forever. So I'll be right back. Be right back. The other thing that is doing there is that is setting to true regardless of whether or not they clicked. It seems that it's doing that. So it might be because of like this event that it sends is different. But I think that's probably easy to solve. I can just put the maybe there is like on the documentation. It's definitely gonna be hard from this, but yeah. So now it's working. And it only works uh, if you press. But it's obviously is still moving this screen, I think. Hmm. So I think that you have to call accept event maybe. Hmm. I think that accept events just for UE. So I'm gonna have to try this one. The problem is that the camera is an O3D, I think, so. What I can, like, if that doesn't work, then I can create another flag variable inside of the camera. And then I just set the flag variable which is true. I'm also not 100% sure that it is moving in the correct way. It seems that it isn't. I think it is. It just stops moving because the mouse goes too fast. Hey, what's up? I think there's probably a flag for this. Yeah, I'm all no, we'll. Hmm. Yeah, so I think I need both probably. So I need to connect this to the mouse as a exit as well. Because the problem is that when you click and then the mouse, like you click and try to drag and then the mouse goes outside, it's going to stop calling this function here, I think. Because the mouse is outside of the object. But it's still, then you like you click and you try to drag and the mouse goes faster, the mouse goes outside, then you release the mouse. It's still gonna be on the state as if it is dragging because I'm setting the flag variable on the function from my class, but the signal stopped. The function stopped here. So I think in order to prevent this from happening, I need to put the both of these events. Yes. I wonder if I can, because so what I'm gonna do is put create setters and getters for the is dragging, and then I'm just gonna bind the value there instead of yeah, I bind the value to the function. And now it should stop from messing up there. So the other thing I was gonna do, so I think that's I have to because it's returning the global position, I think. Road space of the mouse pointer. Location the round space. I don't know if setting the position is gonna work. Like just setting the position. Might just be because I have to do this update here. So I could do, but I think it shouldn't be that because here is already supposed to be giving the position that it happened. But, hmm. Yeah, I think this is a problem I have to convert, I think. Hmm. It's like it's kind of weird because like after you click for the first time when you move the mouse, the but I guess it triggers always. So maybe it is just because like the it seems too slow the move of the mouse like the move of the mouse seems to be a lot faster than the the move of the node there. So either is because I'm setting the position the wrong way or because I have to translate that position that I'm receiving somehow. Because it should be the position of the mouse already. So like I guess like one thing to try but probably wouldn't solve is just create another variable as part of the class and then just update the variable in the beginning and just get the delta in the movements. So like maybe that's, but I don't think that's the problem because it should be a difference, I think. Yeah, so now is going to the left, so it's not the same. Yeah, but now I'm updating the position, not the global position. So like, I'm just gonna do that to make sure that what I have here. Yeah. Okay. Forgot how to do this. I guess you just make it equal after you set. This is the thing that doesn't make sense. Maybe it's minus event position minus the previous one. But I think that's probably not the issue. So this is the thing that's that's, that's so maybe I shouldn't change the Z, I think. Yeah, I should try to do another transformation. So just use the same vector and then just use the camera to get the position. But setting global is kind of the same thing. Oh, it's not camera global as well. Yeah, it's not. Mm. And do this. I think that because I'm receiving the final position doesn't make sense to get that out. But there is something wrong there, and not really sure how to fix. Oh, it's on the camera. No. I think it's because I deleted and then. And the problem is that it doesn't. It's not accurate to like make the movement, the position of the movement the same as the object. Because then like it has to be the projected. Uh, though it seems that this one is the value is a zero, I think, or something like that. It's always going towards the camera. Yeah, I have to understand how the function works, I think. And how are they getting this position here? They're saying that is the world position that the mouse was hit. Maybe I have to translate, I think, to the. The thing is that this should be working because it's the same like coordinates. That's the problem. But I do think that it's probably making the mouse zero. But this one, it doesn't seem that it works as well if I do it this way. This is the last one that I'm gonna try, then I'm gonna stop streaming today. And I'm probably going to go with the debugger to see what is happening. I'm gonna try to see if it's possible to see the function where they're gonna uh, get these values here, so I understand like what it is. Like I don't see why it should be like I think it should be correct because based on the documentation, because this is the global position where the mouse event happened, and then I'm just using that to set the flag variable to determine when it's gonna move the node, and the function is already only gonna be called when the mouse is inside of the object, the collision shape. So this should move the object, should move the global position of the object based on the mouse position. I assume what they're doing is using the some projection function from the camera, and then they get the mouse position based on that, but then the z is gonna be zero because the mouse doesn't have Z, so but like you should get the Z position on the mouse. That's what I so like there's missing information. There's nothing I can do about it without understanding how they got to the value, I think. Because I don't understand exactly like what it means. And also the functions there are kind of confusing to me too. The transform and the basis from Godot and stuff like that. It does seem that it works like this, but it's also moving the camera still. But when I click, I know that is moving. So I'm probably gonna have to just create another flag variable as well for the camera because this seems to be not working. So yeah, but I think that this is the issue. Oh, I guess I can try. If this doesn't work, can you just use get camera 3D function? So I'm basically thinking about creating a flag variable in this camera and then just returning if the flag variable does if the flag variable is such a true, you return the function, and then I just update the flag on this function here, so that it doesn't move the camera when it's dragging the node. But this also seems to be like I think that there should be a function or a transformation somewhere that is gonna allow me to transform this into the coordinates that I can use here or on some other similar function. Oh, the other thing I was gonna do is to print the value. I'm gonna stop streaming now, and I'm gonna try to see if I can figure out off stream. So next time that I stream, I'm probably just gonna continue to follow the list here. So see you then.